Here's a common question and some common mistakes. Here's student 1's answer, nothing wrong here. And here's what the structure looks like in 3D. It's important to realise that single bonds can rotate around. Let's look at what student 2's drawn. This, on first looking at it, looks like they've drawn something completely different to student 1. But actually, because we know that single bonds can rotate around, all we have to do is rotate that methyl group here, which looks like it's on a different part of the chain, just rotates around, and we've got exactly the same as student 1. So those two structures, although they look different, are actually exactly the same because the single bonds rotate. What about student 3 then? This looks completely different to student 1's, but is actually the same structure. This is what they think they've drawn, but this actually, the molecule wouldn't actually be like that because these hydrogen atoms, look, the electrons in those would repel. So student 3's structure is exactly the same as student 1's. Let's have a look at what student 4's drawn. Now this time, when we look at the three-dimensional model of it, you can see it doesn't matter how we turn it, we can't make it into the same shape as student 1's. So this is correct. This is a different structural isomer to student 1's. So these two are correct. Student 5's answer looks completely different to student 4's. But let's trace the carbon backbone. I don't know if you can see that I've traced it in fluorescent yellow. We can see that we have 1, 2, 3, 4 carbons in that chain with a methyl group, look, coming off of carbon atom 2. Go to student 5's, which looks completely different just because it's been drawn differently. 1, 2, 3, 4. That's the longest carbon backbone, methyl group coming off carbon atom 2. So that is exactly the same as student number 4. Here it is rearranged, look, here's our methyl group coming off of carbon 1, 2, 3, 4. It's just rotated the bonds round. Zoom out and we can see here, this is this carbon here, that's that carbon there, 1, 2, 3, 4, and that's that methyl group there, but we number the smallest number 1, 2, 3, 4. So this is still coming off carbon 2. Let's have a look at student 6's work. Now you can see this one is completely different to these two. Here's what it looks like in 3D, and you can see it doesn't matter how much I turn that or twist that, there is no way I'm going to turn that into that or that. You can see clearly the longest backbone we've got is 1, 2, 3. Doesn't matter which way I go, 1, 2, 3, or that way, 1, 2, 3. So this is a different structural isomer to the other two. So this is the answer then. we have 3 structural isomers of C5H12.